Good evening, everyone. I hope my voice is clear. Someone please confirm. Okay. So, I hope you remember last time we completed with inverse trigonometric functions, and now we are going to start with limits. So, before going into today's lecture, let me tell you what we are going to cover here. So basically, we will see like what is the limits. As you can see the content on the screen, we'll first go introduction. What is a limit? Why do we calculate the limit? How do we calculate the limit? What is the use of the limit? Second is understanding limits. Third is existence of a limit. Next is direct substitution method, indeterminate forms, and then L'Hopital's rule. So before starting with this, I hope we can cover until indeterminate forms. So let's start into the chapter. Okay. So let's talk about limits. Now, whose limit are we talking about? See, let me make you understand that basically all the chapters in calculus that we do is basically analyzing the function. Like we start functions from obviously functions chapter, then we move on to limits, continue to differentiability, and then further calculus. So basically the meaning of all these chapters is to evaluate how a function behaves, whether the function is increasing, decreasing, continuous, discontinuous, there is a break in between or not, and so on. So in that, the first step is limits. Now, what does limit do? Like how does limits helps us to evaluate a function? So let us go through that. Whose limit are we talking about? We are talking about limit of a function, obviously, because in calculus we always talk about function. Second, what is the limit? Important. Limit is value of a function. Limit is the value a function approaches. Now, please read it very clearly. It is a value of function approaches, not the exact value, as x approaches a certain value. So by this, you got to know that basically limits does not talk about exact values. It talks about approaching values. Now, we'll go into more detail as we move on ahead. But next, why to evaluate a limit? As I already told you, the purpose of all the chapters in calculus is to like evaluate how the function behaves. Out of this, first is limits. So how does limits help us in behavior of a function? Limits describe how a function behaves near a point, instead of at that point. So by this definition, you can easily mean that function behavior near a point gives us limits. So if I talk about suppose a point x equal to 2, so limits help us to evaluate how the function behaves on the left side of 2, that is less than 2, and on the right side of 2, which is greater than 2. So that is the purpose of limits, of studying limits. Now, this, as we all know, this is a simple yet powerful way and is the basis of all calculus. After limits, everything will involve limits. That's why it's the basis of calculus. And last question, how to evaluate a limit? How to evaluate a limit, that this whole chapter is based on that only. We'll see how to evaluate a limit in this chapter. So I hope the definition of the chapter is clear. Like what are we all gonna do in this chapter? So let us understand what this means, what approaches means. So for that, I have prepared a very simple graph. I hope you remember last time I told you, if you know the graph of a function, I can I can guarantee 50% of calculus I can teach on graph. So let us see. Here, the graph of the function is f of x equal to x plus 2, or we can write y is equals to x plus 2. It doesn't matter, as we have seen y is f of x. So suppose someone tells me the limit of f, which is f is the function at x equal to 3. So at x equal to 3, this is the point, is the value f approaches as we get closer and closer to 3. So as you can see, if I map this on the graph, the value which the function takes at x equals to 3 is 5. But we are not interested in 5. We are interested when the function approaches 3 from left hand side. As you can see, if we move from left hand side of the graph, we approach this value. What is that value? It is 5. Similarly, if we approach 3 from right hand side, from here, meaning if we approach graph from right hand side, what value again we are approaching? Again it is 5. So as we can see that both side, while we approach both side, we are getting the same answer, that is 5. In this case, we can say the limiting value of f as x approaches 3 is 5. Note that this is a notation for x approaches 3. It is read as x approaches 3 or x tends to 3. Tends to meaning same, approaches tends to, you can use both. So what is the limiting value of function? The limiting value of function as x tends to 3 is 5, because from both the sides we are getting 5. So to make it more clear, there is a small animation which you would like to see. This is what I was talking about from left hand side. If we approach the function from left hand side, you can see here, you can see here, as we go closer and closer to 3, the functional value, which is the y value, get closer and closer to 5 from left hand side. Now let us see from right hand side. As we move from right hand side to 3, the functional value, which is the y value, gets closer and closer to 5. Just take 10 seconds and see both the graphs, and you can see that as x approaches 3, y, which is the functional value, approaches 5. So that means, I had said this before, again I said, meaning from both the side, left hand side and right hand side, the function approaches the same value. Meaning we can say that limit of the function as x tends to 3 is 5. And here I have written the definition of limit. As we can see, in a limit, there will always be two cases. Once when we approach from left side, once when we approach from right side. So if both the cases answer is given same, like in this case from left hand side, right hand side, we are getting the answer as 5. So that means that limit exists. If both the sides give the same answer, meaning limit exists. If both the sides or give different answers, then we say the limit does not exist. Okay, so this is the basically existence of a limit. It said that a limit exists if f approaches the same value from both the sides. So this is the graphical concept of limits. Let us move forward and see, like, obvious question, what is the difference between limit of f as x tends to 3 and the value of f at x equal to 3, that is f of 3. So as we know, we do not talk about exact values and limits. We always talk about tending values or approaching values. So to understand it better, what's the difference? Let us take an example. I have taken here a function which is g of x. Now, g of x is defined in two parts. As we have seen, it is like piecewise defined function. We have seen in functions. The first part is x plus 2 if x is not equals to 3, means for any value of x except 3. And the second is undefined at x equal to 3. So if I try to plot this graph, I will get something like this, as you can see the blue line here, where we will get a hollow circle. We will get a hollow circle at x equal to 3, because at x equal to 3, the value of the function is undefined, right? So if the value of the function is undefined, that means we'll have hollow circle here. I hope I am clear. Till now, any doubts? Please, I request you to unmute yourself and like keep interacting. As I've said many times, last time also I said. Okay, very good. So let's proceed further. So in this graph, as you can see, the functional value, that is the value of the function at x equal to 3, is undefined. Now let us calculate limit. How you calculate limit? Limit as x tends to 3. So from left hand side, if x is tending to 3, the graph is tending to which value? 5. Similarly, from right hand side, as we approach 3, the graph approaches 5. Please note, we are not talking about exact value, we are talking approaching value. So from left hand side and from right hand side, the graph approaches the same value, which is 5. So this means that limiting value of the function as x approaches 5, sorry, as x approaches 3 is equals to 5. But the functional value is undefined. The functional value is undefined. So this is basically like to study the behavior of the function. As we can see, we cannot study the behavior of the function at x equal to 3, because that point the value is not defined. But we can study in the neighborhood. Neighborhood means aju baju, means left and right of x equal to 3 by using limits. So here I have written that here the limiting value of g is still 5, as I have explained, but the functional value is undefined. So this is the difference between limiting value and functional value. It is not always possible that the limiting value and functional value will be same, but sometimes it can be same. So that is a very beautiful statement. I would like you all to read. So that's the beauty of limits. Limits is a very beautiful chapter, very interesting chapter. They don't depend on the actual value of the function. Basically, they depend on the value of the function. Yeah, they describe the function as we get close to that limit. So as we move forward and forward, it is going to be more interesting. And as we see the graphs, as we learn the graphs, we will see how we can use limits. So let's move ahead. Now, here is an example where limit does not exist. When will limit not exist? Limit will not exist when the value approach from left and right will be different, as we have seen, as we have understood existence of a limit here. A limit will exist only when the value it approaches will be same. So here's a simple example where if I calculate the limit of the function as at 3, this is the graph of the function, blue line. As I move towards 3 from left hand side, the graph moves towards 4. That means from left hand side, the graph approaches 4. And as I move from 2, 3 from right hand side, so from right hand side, the graph approaches 6. And as you can clearly see, 6 and 4 are not equal, obviously. That means that the value approached from left hand side is not equal to the value approached from right hand side. Meaning the limit is not exist. The limit does not exist. So here is a case, very simple case where we can say limit does not exist. So I hope it is all clear what is the difference between functional value, where does limit does not exist. I'm taking graphs because it is easier for you to understand in case of graphs. We'll obviously take functions with algebraic values. We'll learn that, how to calculate that. So here that is what I have written. When we approach 3 from left, the function approaches 4. And when we approach 3 from right, the function approaches 6. Since limit does not approach the same value from both the sides, implies limit does not exist. So till now, we have studied the basis of limits. What is limit? Why do we calculate limit? And some important terms, existence of a limit. Okay. Let me introduce you one more term. The limit of the function when we approach from left hand side is called left hand limit. The limit of a function as we approach from left hand side is called left hand limit. Or in short, we can write LHL. Similarly, you can obviously assume what will be the limit of a function if we approach from right hand side. It will be right hand limit, basically RHL. So here left hand limit is equals to 4, right hand limit is equals to 6, meaning left hand limit is not equals to right hand limit. So therefore limit does not exist. So these are technical terms you need to remember. Now let's move forward. Notation of a limit. We have studied limit till now by using graphs. Now how we denote limit algebraically. So limit of a function as x, I told you how to write the symbol, x tends to 3 is given as this is the notation. The notation is 3-part LIM, meaning the limit of. This is the value as x approaches 3 or x tends to 3. And this is the function f. Okay. So if someone asks me limit of sine x as x tends to pi by 2, how will I write that? I will write limit of sine x as x tends to or approaches pi by 2. This is my algebraic notation for that. Now, what is the algebraic notation from of left hand limit and right hand limit? Let me tell you. This can be split it in two parts. As we know, we calculate limit from left hand side and from right hand side. So from left hand side, it is called left hand limit. It is denoted by limit x tends to pi by 2 minus. This minus sign indicates that x is approaching pi by 2 from left hand side. That is, if f approaches pi by 2 from left hand sides, means x is less than pi by 2. It's very simple. If we take the number line, let us take number 0. If I approach 0 from left hand side, meaning here it is less than 0. And for RHL, If I approach pi by 2 from right hand side, as you can guess correctly, I hope it will be pi by 2 plus. Pi by 2 plus means we are approaching pi by 2 from right hand side. This means x is greater than pi by 2. Suppose example, if you approach 0 from right hand side, that means that is x will be greater than 0. I hope these notations are clear because algebraically we will be using these notations. Please now, till now, anyone is out or would like to ask something? Please take a minute and check. I hope you communicate with me. Otherwise, the lecture will get very boring. Hello. Okay, okay. Anyone has doubts? Doubts. I'm asking, do you have any doubt? Or did you understand till now everything? Hello. You can talk, like you can unmute yourself and talk. Hello. Okay. Then there is understood. Okay. Chalo. Let's move forward. So now the main part we've been talking about, as we all know, there will be functions or there will be times where we will not be able to make graphs to understand the limits. We would not be able to make graphs. Acha, notation of limit. The notation of limit is very simple. See, this is a notation of the limit. If example I take limit of sin x as x tends to pi by 2. So how can I write it? I will simply write LIM, which means limit of. Here we have to write the function f of x. Here it is sin x. And here below limit, we have to write what value x approaches. Here x approaches pi by 2. Example, here x was approaching 3. Let us take one more example for your clear understanding. If I take limit x tends to 0 of 10x. So how will I read it? Limit of 10x as x tends to 0. The limit of the function f as x approaches 3. So limit of 10x as x approaches 0. I am more familiar with tends to than approaches. So it is okay, it is fine. We can use tends to or approaches. So I hope this is clear now. Notation of limit. How do we write limit algebraically? Please confirm this, that it is clear. Hello. I hope it is clear. Okay, let's move forward. Now, the main thing I've been talking about, that it is not possible for us to make graphs of every function so that we can find the limiting value as we have seen till now. So basically we need tools, algebraic tools, which we can use without using graphs. So now let us see what limits means algebraically. Suppose example f of x is x plus 2, the same example we've been taking. As tends to 3, where does f of x approaches? So we can basically input values of x from left hand side. Means if I go on left hand side of 3, that means left hand side of 3 will come 2.99, means values less than 3, and so on. So as you can see, we have taken three values: 2.9, 2.99, and 2.999, which are very close to 3. So if I substitute these values in the function, I will get functional value as 4.9, 4.99, and 4.999. So as we move closer and closer to 3, here we move closer and closer to 5. So that means from left hand side, that is my left hand limit, will be equal to 5. Now let us see what happens when we approach from right hand side. Right hand side means value greater than 3. Suppose I take 3.01. So here we have taken three values again: 3.1, 3.01, and 3.001. As you can see, as we move closer and closer to 3 from right hand side, the function moves closer and closer to 5. That means right hand limit is also equals to 5. Now, since both the limits, left hand limit and right hand limit, are same, meaning we can say that limit exists. Limit exists and is equal to 5. So algebraically, this is the way we calculate from left hand side and right hand side. Now, in many cases, we directly calculate the limiting value. And how do we calculate directly? It is known as direct substitution method. Direct substitution method. That means we directly substitute x as 3 in the function. As you can see here in f of x, as we substitute x equal to 3, we will get 3 plus 2, which is equals to 5. So basically limiting value is 5. Both are same. So in some cases, we can directly substitute the value or directly substitute the approaching value into the function to get the answer, to get the limiting value. Okay. So here, if we substitute x equal to 3, we directly get 5, which is the limiting value. I hope it is clear. So this is known as direct substitution method. Now, there are many times where the direct substitution method will fail. There are many times where this direct substitution method will fail. So what are those times where this method will fail? Let us look at the example. Okay. Basically, let us look at some examples first. So if I want to calculate this value, what did we do? We directly substitute x equal to 3 in the function. So if we directly substitute, I will get 2 into 3 plus 6 upon 3, meaning under root of 3 2s are 6 plus 6 upon 3, meaning my answer is under root of 12 by 3. This is the examples of direct substitution method. Now, quickly, can you orally calculate the answer to this? Someone, please help me. And can you calculate the answer to this by directly substitution method? Here, there is only one difference. Instead of x, the variable is z. It makes no difference. So, can you calculate it orally? You can calculate it orally. If your answer comes, please let me know. I will wait some 10 to 15 seconds. Still waiting. You can calculate it orally. Just substitute z equals to minus 3 in the function. If you get an answer, you can unmute and say. One upon root 3. Okay. Let us calculate. So if I put z equals to minus 3, I will get under root of minus 3 plus 6 upon minus 3, which will be under root of 3 upon minus 3. And you are very close, is minus 1 upon root negative. Okay, no problem. So the value is minus 1 upon root 3. Now, let us move forward. And as we were talking about, many times direct substitution method does not work. Here is a very simple and interesting example. Suppose I need to find limit of this value and we use direct substitution. Means we directly substitute this in place of x. So I will get 3 square minus 9 upon 3 minus 3. 3 square is 9 and 9 minus 9 is 0 and 3 minus 3 is also 0. And what is the value of this? We don't know. So such cases arise many times in limits. That is, by direct substitution method, we cannot calculate the value of limit. So such cases arise and such forms exist. Here, the form we call is 0 upon 0 form. 0 upon 0 form. So 0 upon 0 form means it is known as an indeterminate form. It is known as indeterminate form. As your English is better than mine, indeterminate form, you already know the meaning, but let me explain. Indeterminate form means the form which value we cannot determine. That is the 0 upon 0. Can we determine the value of 0 upon 0? Please let me make it clear. I cannot write 0 upon 0 and cut it and write equals to 1. As we do in suppose 3 upon 3. We directly cut it and write equals to 1. This is wrong. Okay, because 0 is a very special number. We cannot do things with 0 that we do with other numbers. So yeah, this is not possible. So these forms are called indeterminate forms, that is whose value we cannot determine. One of them is, we can see from this example, it's 0 upon 0. Similarly, we have 7 indeterminate forms. So when we get an indeterminate form by direct substitution method, we need other methods, other tools to come to us for help, helping us to evaluate this value. Now, a bit depending on the type of indeterminate form, we have various methods, that is factorization, rationalization, and so on. So let's look at what are the indeterminate forms. What are the 7 indeterminate forms? So here is a list of the indeterminate forms. The first one we have seen is 0 upon 0. The second one is infinity upon infinity or minus infinity upon minus infinity or any plus infinity upon minus infinity and so on. The third is infinity minus infinity, infinity. Fourth is 0 into infinity. Fifth is 0 raised to 0, 1 raised to infinity, and last is infinity raised to 0. They're called power indeterminate forms since they are in the power. So let me talk more about indeterminate form, which is a confusion, general confusion that many students have here. So let me take four cases, and I would like to know your opinion about these cases. So suppose I will write uh, case 1, exact 0 upon exact 0 is equals to case 2, exact 0 upon tends to 0. We can, yeah. It includes all possible cases, minus infinity upon plus infinity, all the possible cases. That's why I wrote plus minus 7. So there are four cases. You are right. Third, tends to 0 upon tends to 0. And fourth, what is remaining? Yeah, tends to 0 upon exact 0. So these are the four cases. Let me, before going into this, let me make a cloud here and see what are these values. We can see 0 upon any number is equal to 0. And any number upon 0 is basically not defined. So I hope these two parts are clear. Then you can try to attempt these four cases. I'll give you 20 seconds to think, and if you, then I'll give my answer. You can try any four. You can try to give any answer for the four, any four cases. Keep this in mind and then approach this. So it'll be easy to understand. And also tends to 0 means, that means if I say x tends to 0, meaning x is not equal to 0, obviously, because if x is tending to 0, it is close to 0, but it is never 0, as we have seen till now in limits. X tends to 3 means it is close to 3 from both sides, but it is never 3. Very, very important. I hope you noticed this till now. Tends to 3 or tends to 5, meaning it is very, very close to 5 from both the side or for either side, but it is not exactly 5. If we get exactly 5, that means we are using the functional value, as we have seen. And there is a difference between limiting value and functional value. So I hope you didn't get answer for any of these. Okay. This is your first time, obviously. So when it was my first time, I also couldn't get any of the answers. But let me tell you now, what are the answers? So exact 0 upon exact 0. Now, in this case, I am not worried about the numerator का zero. Let me change the color. I am not worried about the numerator का zero, because as we have seen from this, if numerator में zero आया, then it is zero. I am worried about denominator zero, because if denominator has zero, then it is not defined. So here, the answer to the first case is I am not absolutely worried about the numerator zero. I am worried about denominator zero, because zero in denominator makes the expression not defined. So you can say same is case with 4. I am not worried about the value in the numerator, but in the denominator it is exact 0, and 0 in denominator makes the expression not defined. You can see here. So that leaves us with these two cases. Case 2. Case 2 is exact 0 upon tends to 0. Tends to 0 means it is very close to 0. So I can write suppose 0.001. And as we all know from this one, 0 upon any number which is not 0. Or as I would like to say, 0 upon non-zero. 0 upon non-zero, the answer is always 0. Common sense. Here it is 0 upon non-zero. I mean, it depends. Non-zero, what is in place of non-zero? Here it was 3, here is 0.001. This is the case of our interest. Tends to 0 upon tends to 0. This is mainly my indeterminate form. Let me explain why. Because tends to 0 means a quantity which is close to 0. So we have infinite possibilities. If I write 0.001 upon 0.01, this is one of the possibility of tends to 0 upon tends to 0. Or if I approach from left hand side, I can write minus 0.01 upon 0.0001. Or I can write 0.1 upon 0.01. There are endless possibilities. So since there are endless possibilities, we cannot give a definite answer to this. So if we cannot give a definite answer, such forms are called indeterminate forms. That is a basic definition of indeterminate forms. The forms which we cannot give any answer. So please note, out of these 4 cases, my only indeterminate form is the case number 3. Because in case number 3, there are infinite possibilities, means infinite answers, which we cannot give a definite answer. So the confusion I was talking about is these 4 cases. We will say this indeterminate form as 0 upon 0, but in our mind or at the back of our mind, we should know it is tends to 0 upon tends to 0. Obviously, we will not every time say tends to 0 upon tends to 0. We will say the indeterminate form is 0 upon 0. But at the back of the mind, you should always remember it is tends to 0 upon tends to 0. So, as you can see, all the other values here are also not exact values. They are also tending values. Here I have written in bold all the values in the indeterminate forms. Bale, if we read as exact values, but they are tending values. As we read it here, 0 upon 0, but we know that it is tends to 0 upon tends to 0. Same is case with other. So suppose I say example this. This is not 0 raised to 0. This is tends to 0 raised to tends to 0. Here, this is not 1 raised to infinity. Though we will read it as 1 raised to infinity, but we know that it is tends to 1 raised to tends to infinity. And same is with this and all the other cases. So I hope this is a major confusion for the students. But if you go through these cases again, case 1, case 2, case 3, case 4, and try to evaluate what we have done here, you will get a very clear idea of what are indeterminate forms. So I will give you some 30 seconds to again go through these four cases and be very clear on what are indeterminate forms. We do not talk about exact values in indeterminate forms. We talk about tending values. And since we talk about tending values, we talk about limits. So I will give you 30 seconds. Please, everyone, pin drop silence. Like, no need to talk. Just focus on the screen and try to go through these four cases. Okay, done. Please, if you have any doubt, clear it right now. Please clear it right now. Anyone, if you have any doubt, please clear it right now, or else we'll move forward. No doubts? Okay, very good. You all, I have to tell all the students, your grasping power is very good. Because for the first time, let me tell you, when I learned limits, I couldn't understand a thing. When I was in 12th standard or 11th standard rather, when limits was introduced to me, I couldn't understand the thing because it is very logical, but it takes some time to be familiar with what are we talking about. Because till now we were talking about the exact values, and achanak se we were talking about tending values. So for me, it took like almost 3 to 4 tries, 3 to 4 times I have to go through these so I can understand properly. Superb, superb, very good. So let us move forward now. Before coming to indeterminate form, we were talking about like there will be cases where we couldn't uh, find the value of a limit by direct substitution method, and those cases will be the cases where indeterminate form appears. So, what to do when indeterminate form appears? There is, we can say, a method which we can apply to 90% of the times. We can apply to 90% of the times. So, that is the only method which is this vast. Like, we can apply 90% of the times. So, first, let us go through that method. That method is called L'Hopital's rule. As you have seen in introduction, L'Hopital's rule. But for this is obviously this is scientist name L'Hopital. So before this, but we need to know the basic formula of derivatives. Are you aware of derivatives? You must have learned them in physics. Have you done in maths? Please, someone tell me. Have you done, acha, what is value of infinity upon infinity? Yeah, we'll come back. But you have done basic formula for derivatives, no? Have you done it in maths? So you will be aware of this formula. So yeah, your what is the value of infinity upon infinity? That is what we that is there is no value of infinity upon infinity, na? Like we cannot just cut infinity upon infinity and write it as one. Because let me give you a very simple example. The way I understand infinity upon infinity form is, uh, suppose say I reach infinity. Somehow I reach infinity, and let's say that value is 5 crores. Like let us consider 5 crores as infinity. Now, you all have heard, must have heard that uh, like we cannot ever reach infinity. So suppose for one time say I defined infinity as 5 crores, then obviously there will be a number which is greater than 5 crores, meaning which is greater than infinity. So what is infinity upon infinity? It's basically, suppose greater than 5 crores, there will be 6 crores. So if I write 6 crores upon 5 crores, there will be 7 crores. 7 crores upon 5 crores, there will be 8 crores. 8 crores upon 5 crores. So basically, all these values we cannot uniquely determine, as you can see. Now, let me explain it in case of infinity upon infinity. So if I simply take infinity upon infinity, so what I will say the value of infinity plus 1 is. What is the value of infinity plus 2? What is the value of infinity plus infinity? I hope you understand. Infinity plus 1 is also infinity. Infinity plus 2 is also infinity. Infinity plus infinity is also infinity. So this brings me to a nice sentence which I heard somewhere, that is, some infinities are bigger than other infinities, meaning this infinity is bigger than this infinity because it is one is getting added. So similarly, therefore, we cannot compare infinity upon infinity form. Like we don't know which infinity is bigger out of these two, right? Because this value is also called infinity and this value is also called infinity. So we cannot tell which is bigger. So that's why we cannot define or uniquely determine its value. So that's why it comes in indeterminate form. I hope it's clear now, right? Please, you can confirm this if you understood what I'm talking about, why infinity upon infinity is here. Yes, super. So next I was talking about, like, the derivatives. So I hope you know all these formulas. Obviously, they are on your screen, and again I will make you revise the formulas of derivatives, because for L Hospital's rule, or I would like to say LH rule, L Hospital's rule, every time it is not possible to L Hospital. So for LH rule, we will need this formula of derivatives, and again the rules of derivatives like addition, subtraction, the UV rule. You will be familiar with UV rule part. UV rule, U upon V rule. So do you know these rules? Please, someone confirm this. Do you know u into v and u upon v on all these rules of derivatives along with the formula? Yes, anyone please? If you know these rules, then we just need to revise the rules and move forward. If not, then we'll have to first learn the derivatives part. But I think you all should have known because it already comes in physics at the start. So, yes, anyone please say ki you know these rules and the formulas because we need these two things and then we can find the proceed with LH rule. Hello, is my voice clear? Are you done with this in physics or maths so we can proceed further? Learned, na? Okay, fine, fine. So again, obviously, we will revise this, and I have also some examples here to revise the derivatives. We have to find the derivatives of all these functions. So we will brush up the derivatives part, and then we will go with LH rule. And there are questions like there are many questions you can do with LH rule. So here we have taken some questions. We'll solve these questions. Today's time is up. So tomorrow we'll go through derivatives, formula, and rules, and then we will see how to apply them in LH rule. And let me tell you the sequence of the chapter. I hope I have, you know that after limits we will be going with continuity. So once we complete limits, most probably from next week we learn continuity. So I hope this all is clear. So we'll leave today's class and meet you all tomorrow. Okay, I hope this was a fruitful class for you. You understand something about limit, the indeterminate forms and all. Okay, so yeah, let's end the session today. Thank you all for joining. Bye bye.